record. So I will thank you all for coming. As I mentioned a second ago, about 18 months ago, I did a series of quarterly discussions around a topic. In that case, it was data and the size of the industry and subparts of the industry and so on. Over the course of the last 6 months, I've had a number of conversations with primarily general contractors, but not only, where I think there's just a lot of conversations going on around AI, and we're skipping to the product part, I think, too often. So what I wanted to do here is level set a little bit and go through what some of these things are, but then get into what they mean and hopefully introduce some ideas, some things that you'll have seen before, but also some things that that you haven't before, or some perspectives that you might not. The idea here is to do this once a quarter, to explain some things. Like, I'm not going to go deep on LangChain and fine tuning and all that right now, but those are all good ideas and good things to learn about. I just needed this not to be too long a session. So I'm going to aim to make this about an hour. I've left about a half an hour for conversation. That said, don't be shy about asking a question along the way. If I can, I'll stop and answer it. Sometimes I may be on a roll, as happens. So with that, we're calling this AI in construction. The idea being that as I mentioned, over the course of, hold on a sec. Over the course of at least a year, once a quarter, we'll talk about what's going on. But also, we're doing webinars along the way that are diving into workflows and so on. Wide open for anyone who'd like to have a conversation about this, be part of it, ask me questions, so on. I'm kind of a geek about this stuff, so I'm out there doing the hard, some of the reading that you don't have to. At the end of this, I will have some resources for you to check out, because there's some fantastic stuff out there that is a little less full of beans than some of the other options that you might find. Why this series? So I have this feeling, and I'm sure a lot of you do too, that this round of AI is coming faster than any other software I've been a part of, or really any technology that I've been a part of. You've all seen things like this. The ChatGPT thing was just weird. But even if you bent that curve a little, it's still insane how fast it came and how different. And I'll tell you what it reminds me a little bit of is, and this is going to date myself, the way AOL felt back in the 94, 95, when the internet, it was just this set of possibilities you hadn't considered before. More of an analogy than anything else, but that's what this moment feels like. And ultimately, how you think about AI is going to drive the choices you make, whether to investigate it further, discount it now, or say yes or say no to various options that are being sent your way, whether they're products or whether they're services, whatever. And I want to give people at least the nomenclature and baseline understanding to ask good questions and say yes with confidence, but also say no with confidence. We're now at that moment for sure, and I think we'll be here for a little while, where there's a little bit of pressure to be doing something with AI, either from senior management or from someone or whatever. Being able to explain why you didn't do something is at least as much fun as being able to say why you did something. So I'm going to start with, as I mentioned, a definition, a little bit more than just a couple of words here, but really getting into that, and then thinking about a typology. So by that, I mean, we tend to lump things together, and there is more than one kind of AI, which a number of people on this call I know are working with more than one type of AI. I want to look at what that is, and then think about what are the capabilities of these different types of AI, and what are the risks. So one of the things you'll hear me talk about a lot is, what risks are we creating? How does this fail? And what should we be worried about, even if we're not quite ready to adopt? Still, what should we be thinking about? I'm going to end with economics and a view from some pretty smart economists from University of Toronto that I really like. Some of you may have heard of them. And I think it puts AI, especially generative AI, that has a little more of a capability to replace jobs, I think, than deep learning did. At least it feels like it does, in different perspective. All these are all thought starters. As I mentioned, if I can, I'll answer questions along the way. We've got at least a half an hour at the end for a real robust Q&A. And as I mentioned already, but if you just come on, we are recording this as fast as I can. I'll put it up on YouTube, and you'll be able to do whatever you want with it after that. I will probably do a pretty good transcript of it as well. I'm certainly going to do a rough transcript, but I'll try to clean up a proper transcript also. So let's start with, what is AI? all of you have seen some, article or something that's got a shiny robot doing some human-looking thing. And I think for all intents and purposes, it's not this. This is distracting. It's unhelpful. It's down the road maybe, but not relevant to any conversation or decision that most people on this phone are making. We're not talking about super intelligent things that can, I don't know, do super intelligent things. Well, a useful definition is AI is software that can do things without explicit programming, often via learning. In fact, the thing that really kicked it all off was a version of machine learning called deep learning, which everyone's heard of. So that's a useful way of thinking about it. There's a little more in that definition that I want to be careful about, and that is this idea that AI is software. So, on the left-hand side, I've got two examples, and obviously Autodesk has AI that they're playing with, using, so on and so forth, so hopefully nobody's going to get mad at me. When you think about what Revit did, you push a button, it does a thing. Excel, you push a button, it does a thing. Alexa is able to understand what you say, as is Siri and 15 other things. It is able to do things with nuance that is a lot harder, and there is no number of instructions you could write that would allow it to effectively understand what you say. We know this, especially when it comes to voice, because Dragon tried that in the deep learning age, and it was not terrible, but it wasn't very good versus the quality that you have now. The other thing to note when you think about data is how much better Alexa and Siri got over time, because they just had absolutely billions of data points. Construction site, and of course, this will be one of the few times you see my company's logo. So what I'd like you to take away from that little definition is that, first of all, AI is software. It's math, it's not magic. It's important to compare AI to software, not to humans. As you're looking to adopt AI, one of the mistakes I see people make on occasion is compare it to what a human, and we can't help ourselves, especially when it sounds really human-like, like a large language model might. You have to remember, under it all is math, and it's not a silicon brain doing things almost like you do. It's doing them dramatically differently. It's arriving at its conclusions, it's arriving at its decisions in a way that is very different from how a human brain might. So as you think about AI, again, always keep in mind it's software. It's better than other software in important ways, but it's not better than other software in some others. It's math. It's not magic. You don't sprinkle AI on anything. And this is relevant because you're going to start hearing, the opportunity to plug in, some API from Microsoft or from wherever, and just, put your data through it, and it's going to do wonderful things. That's just not practical. There's always going to, well, anyway, within a time frame that anyone cares about, you're still going to have to do fine tuning, training, some level of work that's going to require some level of feedback and tuning, for lack of a better word. And that word tuning gets used a bunch of different ways, but nevertheless, it's not magic. It doesn't just work. It's going to take some effort and work to get there. Okay. Thank you, Isaac, for putting my YouTube channel up there. Also, I have a quick point, just given some of the chats back and forth. I have a list here from on LinkedIn. It's not literally a list where I'm going to start bugging you and trying to sell you, toothpaste, but I can let everyone here know where the link is if you ever want it for this talk. All right, so types of AI. There's really a wave zero, which is the 60s, but they didn't really produce anything useful. So the 70s and 80s, there's a thing called expert systems. Almost nobody on the call have been paying attention when this happened. They really tried to put a bunch of rules and procedures together. It wasn't very good. Ironically, I used the word no nuance. The company that did the best job with Dragon software, I believe they were called Nuance. They did things like documents and simple things, medical applications where they were doing some things with medical documents and so on. I believe the legal profession, they did some things. A lot of this just became algorithmic software. So it sort of petered out because there's just a limit to how many rules you can write. I'll give you an easy example, or an example anyway. In the learning space, like the teaching, e-learning space, there was a thing called intelligent tutoring systems. And they, at one point, an academic, they created one where they were writing 500 hours of instruction. Like they were spending 500 hours of instruction for 1 minute of actual user experience. I mean, it just got insane. That kind of petered out, and then there was what they call an AI winter, which was really the second one. Then out of the University of Toronto, deep learning got to a place where it was not just practical, but it was beating every other kind of machine learning. And it was so much better that it sort of took over. And that's why a lot of people remember in the 2013, 2014 time period, suddenly we were hearing about AI a lot. It was deep learning you were hearing about. It's a flavor of machine learning. I have a little bit more to say about deep learning in a moment, but data is basically, again, processed by math, very good at classification. This is where we found things like sophisticated voice, image, video recognition, and processing. And as we'll see in a moment, almost every AI you're actually using right now is probably deep learning or some variant of it. The thing that's got everybody excited is wave three, and that's generative AI. That was, I mean, look, it's been around longer than this. It's been around since 2017 when the transformer idea came out, and you'll hear more about that in a minute. But it really took off when they figured out how to make it useful to regular people, regular consumers, which wasn't very true beforehand. It was kind of a geek's toy before that. You had to really understand it. The key thing here is this is another version of deep learning. They have a new algorithm and a new approach, but it's a huge scale of deep learning. You're talking about all training some of these models with all of Wikipedia as an example. ChatGPT is one of them, but also so are the diffusion models like Stable Diffusion and DALL-E and a few others. What's interesting is that human level language and visual processing, not thinking, the reasoning we're seeing from it is still being explored, but it clearly doesn't have world knowledge like a human. This isn't anywhere near AGI. It's just really, really good at certain things. And also really good at sounding very fluent and erudite, which is distracting, to be honest. Cool, but it also, I think it makes people think there's more going on than there might be. So why you should care about these three different types, and I'm really going to focus on the second two. The first one, as I say, is sort of become software, is they succeed differently. They're good at different things, but they also fail differently. And ultimately, the real question that most people are asking is, well, the two are, why would I want to adopt this? And then what do I have to worry about if I do? And so how does it succeed if I say yes to it? And how does it fail if I don't? These are pretty complicated things. To really dive into this, every one of these questions would be its own hour. So what I'm doing today is giving you the beginnings of some things that we've seen out there so you can either pursue it yourself or come next month or come next quarter and we'll go deeper. So before I go into the success and failure, though, I want to talk about how you do these things, because it's worth also having a passing knowledge of how deep learning works, because you hear the outcome of this so often. Whenever you hear people talk about AI, they almost always talk about data. And it's important to know why they would talk about data. Why does it matter other than garbage in, garbage out? That's fine. Garbage in, garbage out is as good as far as it goes, but it doesn't go very far. Like what does that even mean? Three ways that we've done deep learning in the last decade roughly. One is called supervised learning, and I'll define that in a second. The other one is unsupervised learning. And supervised learning is a classic example of people who are deep in something, naming something without realizing how it's going to sound outside of their kind of milieu. It isn't a person there with their arms folded, tapping their foot while the learning happens. It actually means you've labeled the data, and I'll get to that in a second. The final one is reinforcement learning, which is often the hardest of the three, but some of the craziest stuff has come out of reinforcement learning. Like for those of you who are familiar with DeepMind and their ability to basically beat every game that's ever been invented by humans, it's reinforcement learning that's doing that. And actually, we'll get into the other way that OpenAI has used it. So when you think about supervised learning, it is really the king of current AI. Almost everything that's in production is supervised learning. That's not going to stay true, but for the moment, it's pretty true. Typically, you need hundreds of thousands of data points that are labeled. So imagine if you wanted to, in fact, the very first thing that the University of Toronto folks won at was an image recognition model that could differentiate dog breeds. So what they had to do is come up with thousands and thousands and thousands of different pictures of dog breeds that had a label next to them. So this is a Schnauzer and this is a Basset Hound, whatever. That's what supervised learning. When they say supervised, they mean that you're telling the system what it's looking at so it can learn. You run this through a thing called gradient descent, which if you ever have trouble sleeping, I'm happy to explain. That reduces the errors to the point where you're doing as good a job as you need to be. And in a moment, we're going to talk about what that even means. The accuracy that you're going to need is actually one of the key questions that's part of AI. An analogy I like to give people of supervised learning is linear regression. Some of you may remember this. Hopefully, I'm not triggering anyone's bad memories. But linear regression is you got 2 points, and you plot a number an equation that describes the relationship between one and the other. Look, this is just an analogy. It isn't really linear regression. The reason I say it is you're relating two things to each other, the label to the picture or the item or whatever it is. So as you think about what happens with linear regression, if I have a ton of data over here, suddenly that line is going to point up a little bit. And that is why bias is so important to understand and guard against. You hear about it often in sort of social context, but it's a bigger problem than just having too many of one group or whatever. It's a problem every time you're trying to use deep learning, specifically supervised learning, because it will give you bad answers. Whatever it is, if you're trying to predict what the weather's going to do to the pane of glass or to the mud or to whatever it is, if you have not collected your data intelligently, you're going to have a bias problem. This gives you an analogy for why. It's much more sophisticated in deep learning, but it does boil down to a lot of the same things. And as I said, this is why bias is bad. So that's supervised learning, and I've smoked through that one kind of quickly. There's a lot of really good material out there on explaining supervised learning. I think hopefully that was enough to get you started. Unsupervised learning often happens before supervised learning because the world doesn't have labels on it. So a lot of times people are taking tons and tons of data, typically a lot more than supervised learning, and the system itself is discovering the labels. It's saying, I think these are the categories out here. Usually humans involved in eyeballing at it. It's not automatic. But often it'll find categories you didn't know existed, which is one of the reasons it's really powerful. Then the system reruns it as supervised learning. So very often unsupervised and supervised learning happen together. As an example, this is actually what unsupervised learning is part of what goes on with large language models, a point that is pretty technical and we can talk about another time. The final one is called reinforcement learning. And this one's important because each of these is effectively, the supervised learning and unsupervised learning are basically telling you how to classify something. It's a point in time. In contrast, if something is a multi-step process, and a game is sort of an extreme example of that, this is where it matters the most, or this is where reinforcement learning is valuable. The system will run and it's given points for success. So one of the things that designers and engineers spend a lot of time on is thinking about how those points and that how to teach the system by giving it rewards when it gets things right. It's harder than it sounds, because if you just give it a reward for winning, it's crazy what AI will sometimes do. It'll find loopholes in the rules that you didn't know. An example, there was one where a company had built a game where you had to drive your boat and pick things up. And it turned out that what they were trying to do was get it to play multi-step game that had you go to different levels, but it would win by just finding one of these little things you run over and get points, and it just would go in circles. And that's one of the issues that happens with AI is a lot of times as humans, we bring so much world knowledge and common sense to things, it doesn't even occur to us to cheat in some of the ways that AI will, because the rules didn't tell it not to. So it found the fastest and most efficient way to achieve what you'd asked it to achieve. This is what makes reinforcement learning a real art, and what makes it really powerful once done right. So folks, those are the three ways to think about deep learning. And again, you're going to recognize a lot of these in things that you use now. And again, a lot of the AI companies with AI in their name are saying they do AI. One way or the other probably use one of the deep learning, almost definitely use one of the kind of traditional deep learning methodologies. An example of that is almost anyone doing something with documents has a natural language processing model, at least one, somewhere in there, reading what you're putting into the system. They're just everywhere, and they're not very expensive to use and to tune. So these are just some examples of companies that are using deep learning. So now we're on to the big stuff. And keep in mind, this is all, it's incredible how fast this is moving, but it's still very new. So deep learning, you can think of it as predicting a point. It's helping you classify a thing or set of things. Generative AI predicts a passage or a picture, and that literally is what it's asked to do. The way a transformer works is what would come next, given what's been said or provided so far. And often that's a lot, and you can tell it, you can give it parameters, but it'll produce a large body of responses based on context, not just on one thing. And that's really important, is it's looking at what it knows and then what you've given it to complete the question or to answer the question. So for those of you who want to dig into this, it was made possible by an approach called the transformer. So when you hear the word GPT, chat GPT, or a GPT-3, transformer is what the T means. The other one is, I believe, general purpose transformer. That really was one of those moments that changed a lot of things. It was in 2017. It gives you an idea of how long it took to really kind of get where we are now. The paper Attention is All You Need is not it's not the easiest read in the world, but it's not a bad thing to have a look at, or go on YouTube and see if somebody explained it in a way that you find useful and compelling. So this is what, when we say generative AI, why it's different, again, to give you an intuition, is it's not a point, it's a context. It's longer, it's a passage. That's where you'd use one versus use the other. And again, these are generalities. I mentioned reinforcement learning before, and I said I'd tell you about it again. Here is what changed. The thing that happened in November is OpenAI published ChatGPT, but what was different, the underlying model had been around for at least a year, GPT-3. They innovated a thing called reinforcement learning with human feedback, where they literally had humans rate the responses that were coming out, and it got very good at clipping and suppressing, for lack of a better word, responses that humans didn't find valuable. It basically tuned the system at a massive scale. And this tuning thing is important because it's become part of how we think about generative AI and how to actually make it useful. Okay, so looks like there's a lot of conversations in there. So having gone through what we're talking about, now I'd like to go and talk a little bit about what makes these things succeed and what makes them fail. Deep learning succeeds by automating the classification of things in the world. And this is a more powerful idea than it sounds like. The guys from University of Toronto, for example, will point out that things like digital imaging, like digital cameras, that's just math. That's just basically just arithmetic. But it's so much of it is done, and it's so cheap that entirely new things become possible. So the idea, the ability to automate the filling in of information you don't have, which is really what we mean when we say classification or prediction. The ability to do that at huge scale means all of a sudden I'm able to do things with images, with videos, with language and speech, even processes, games, and interactions that you just couldn't do before. So this sort of a thing is where we have seen deep learning succeed, and where, if you have to manage things like this that are relatively straightforward, that are more of a point than a plane, for lack of a better word, or more of a point than a passage, deep learning is going to help you. So that's classifying what it sees, classifying maybe what it hears. Deep learning is very powerful and only going to get more powerful. There's still innovation going on in the classic deep learning world. Where it fails, it kind of boils down to the data. There's definitely an issue with whether you're using the right algorithm or not, but that's so far beyond anyone on this, most people on this call. The reality is, what you can control and be concerned about is the data complete? Is it, and when I say complete, I don't just mean is it covering everything? Is it covering everything in a roughly proportional way? Just like would be true if you were doing a survey. You wouldn't want to oversample one group versus another, but that's true for things beyond people. Whatever you're gathering data for, what is really important is to understand, is my source representing the underlying truth, whether that's weather, whether that's incidents, whether that's the height of your hammers, which is a real stupid example. You want to make sure that you've done your best to sample pretty thoroughly. The other thing that's important is almost never is it okay for AI not to have a human in the loop somewhere, even if it's sampling. The exception is when your accuracy can be pretty low, and I'll get to that in a sec. And low can be 80%, but otherwise you really need a human in the loop. That's not going to change anytime very soon. Bad data I mentioned before, biased data. And then the final thing that is a really important point that I don't hear often enough. So a couple of years ago, I heard a young guy, he's not that young anymore, but talk about the number one thing to understand when you're creating AI, and that is to ask what your accuracy level is. So in other words, an Amazon recommendation can be 75% accurate, and I don't care because it's not mission critical. They're just suggesting things. In contrast, and as a result, we had them pretty early and they added value. In contrast, this same person, the founder of Scale.ai, was talking about self-driving cars, and this was 2018. Some of you may recall, 2018, everyone thought they were like around the corner. Literally, they were saying 2019, we're going to have cars on the road. And he's like, no way. You know, right now, the accuracy is so hard to get at the level that they need it to be, that every increment is the same amount of data as you had up until that point. It's the worst kind of logarithmic scale. And as a result, we still don't really have them on the road. They're getting there. And this has been a pretty good summer for some of the tests. But it tells you the difference. It shows the difference between how accurate you need a thing. But it also speaks for those of you who sometimes are concerned yourself or hear concerns about AI taking an entire job. And this is an argument against it, is to be accurate enough to replace a human. There's almost nobody has enough data for that to be true. And the reason is you don't have to train a human on anywhere near the same amount of data for a human to be pretty fault tolerant and good at, you know, doing at least sort of the right thing in a new situation. And this is sort of the representation of the point I made, is any AI project, especially deep learning, the first question should be, how accurate do I need this to be? And what happens is, and there's more going on in this chart, even though it's kind of goofy with the, you know, it looks like I made it with a crayon. What happens with AI in the beginning, because you're in a demo situation kind of along the bottom, every new increment seems like it's getting better and better, and I don't need too much more data. This is awesome. My gosh. But then you get towards 80, 90%, and suddenly it starts to get really hard because now you're talking about cases that don't happen very often. So being able to be truly 99.9% is just really hard. And that's an argument for, number one, asking yourself, does it need to be that accurate? And number two, including a human in the loop, which again, you're going to need to see for a while. This is why you often hear people talk about augmentation versus automation. Is, you know, being able to automate a part of a process, but a human still in the loop is very doable and very achievable. Literally replacing a human or not having a human in the loop is just beyond what most people are able to do. And that kind of brings you to a bit of a cheat code. One of the things that you hear about a lot is that companies in production, like really using AI, will often have more than one model. And the reason they do that is they make their problems smaller. So as you think about what you might want to use AI for, one of the first questions, and certainly one of the things you should ask yourself and tell yourself repeatedly, is how do I make this problem smaller? Frankly, that's not bad with humans either. But saying, how can I make the fewer variables, better input, so that the gap between problem and solution is tighter? Can you give it more similar use cases? Can you have it doing fewer steps? These are just examples. But a general question is, anytime that you need to make something bigger, the problem more complicated, more inclusive, you're going to need more data. If you can make the problem smaller or break it into pieces, you're going to need less data. And in a AEC world, we're getting data that's well labeled and also is organized and structured the same way at any level of scale is just really hard to do. Being able to make your problems smaller is a good idea, and I think that's something that hopefully all of you will take. Of the takeaways, this is kind of a big one. Okay, Marcus, hold on. We'll get to that in a minute. When generative AI succeeds, so this is where you're getting longer answers, better new context summaries. Again, the way to think about generative AI, at least a big part of thinking about it, is thinking about context, thinking about a bigger view of what you're looking at. And that's, it's a much bigger model, typically 2 or 3 orders of magnitude bigger than deep learning, than other versions of deep learning. But also the way it's trained is explicitly about context, as opposed to kind of the regression example I'd used earlier. So really good at summarizing documents. You're seeing this now. Really good at writing emails, comments. Good at creating imagery plans. So again, these are the things that you're seeing out in the market right now. What I know you're going to see more is actually, because it can write code and because it can do certain things, you will see more and more of AI, of generative AI acting as an agent. And now the question becomes, how far do you trust it to act? And I think one of the things that you're going to start to see is people measuring whether a model can do one thing, whether you can let it do 2 things in a row. So how many hops can it do without a human supervising it? That's a thing that we're all going to work out, and it'll be pretty product specific, I think. So some functions that we've already started to see is, easy access to project details, because it can do things like named entity extraction, which is basically reading a document and pulling out key issues that you might want to look at. Summaries of project information for pretty much the same reason. Tailored reports so it's good at writing things. First drafts of things like RFIs, because again, writing the first one and having a person look at it is again the sort of human in the loop idea. I think you're going to see a lot of transformation of dark data. I also think related to and by that I mean PDFs that are unstructured, but there's important information in there. I think between named entity extraction and some other things we know generative AI can do, you're going to start to see some of that. To the point where a decision might be made, how much do we even want? Similarly, I think that some of the businesses out there that connect data from one point to another might find that that's a pretty automatable thing. I have a feeling that's coming. In short, the technology will absolutely change the role information plays in job execution, and here's some ways. There's a lot of smart folks trying different things, adding this into their existing product, which is great because usually they've got good data and good process and good customer understanding. So I think you're going to start seeing really good things come from vertical companies that have been around a bit, who really understand their customer and what their needs are. I have a feeling that Microsoft and some others will have some general tools that with the right IT department, you can do some interesting things with. I also think it's not crazy to think that these generative AI, offerings might make IT departments grow. Because in other industries, it's stuff like this that makes you want to have more people to make use of it. How it fails, there's really a big one right now, and that's it creates an answer when it doesn't know the answer. And it does so in a way that is really compelling. It's very fluent, and you're like, oh, obviously this is right. It sounds pretty confident. The whole point of it is predicting what it should be next based on this massive training. It'll pull from its memory if it has it, or pull from the documents you give it. But if not, it's probably still going to answer the question, which is, a thing that is getting solved pretty quickly. There's a couple of ways to do that. We'll cover in a later session. One of the things you're seeing is, again, inappropriate data, copyright infringement is getting figured out. These hallucinations, or what, I don't know why we call it that, but that's confidently telling you things you don't know. One of the things that is at least a big risk as anything else is humans' natural anthropomorphizing. So we think things are human and we treat them like they're human, even when they're not. And we're going to be particularly susceptible to this because they sound so human. They sound so fluent. So I'm going to slow down here a minute, because this is kind of like making the problem smaller. The concept of failure modes is more like a class of things than an actual one thing only. It's important to understand that AI and the anthropomorphizing is important here. It will not fail like a human would. Just because it sounds human doesn't mean it is. It's not a silicon brain. It is fundamentally different from how humans arrive at our decisions and our whatever we say. And that's going to take a while for it to sink in, and it's going to take a while for us to really get good at. We are literally talking to an alien intelligence, even if it's only as intelligent as a particularly dumb dog. But the most important concept is really understanding how it might fail and asking that question, because it'll be different for different executions and different products. The outputs, they look right. We trust them. It's really capable, and most of the time it's doing pretty great stuff, but that hides the moment when it fails you. So how are you systematically understanding failure modes and systematically protecting against them? A great example of this, my colleague, Andrew, I think you're the one who sent it out. There was a study done by a group in Israel where they looked at the responses from ChatGPT in a pretty systematic way and found that it had varied over time. And I'm kind of making a hash of what their findings were. The point is that it was drifting in how it was answering questions, which is important because if you're relying on it to be accurate and consistent, right now they're still working on what that even means. So understanding failure modes is not going to go away. It's going to be a part of using AI for a while. I don't know what that means, but certainly for any time frame that this group cares about, asking what's the failure mode should be one of the questions you ask someone who comes to you and says, I've got an AI and it can do great stuff. So I'm going to take just a second, just have a look. Okay. Marcus, we can answer that question later. So to illustrate my point about failure modes and how you can get surprised, some of you have heard me use this example in the past. So I think it was 2016, there was a researcher who built a model that could recognize dog breeds again, probably because he was competing in the same thing. And they realized they kept having a problem where it couldn't differentiate huskies and wolves. And a human would say, well, that's because they kind of look alike. Right? Like that's our problem is we look at how AI fails and we immediately will start to wonder why and we'll make up reasons because we know how a human might fail or how a human might make that mistake. But it turned out that both wolves and huskies had snowy backgrounds in all of their photos. And this is another example of really paying attention to your data. So it learned that everything with snow in the background is a wolf. So it was making its decision based on what we think of as an irrelevant part of the data, but it doesn't know that because it doesn't understand the world. So this to me is a really powerful example of how AI can fail without us knowing how it did. And in a surprising way, if they hadn't really dug into this, they wouldn't have known why. They may not have even known that it was if it was too automatic. So I've kind of gone through now, a good definition of what AI is and broken down some of the ways that AI shows up in the world, but including how it fails. I'm going to spend a little time now talking about the economics of it. And first, I want to in a sec, I'll make sure you understand something. What do we really care about? So what are the questions that economics would help us with? Not the first one, but an important one is it going to replace people? Is it going to improve business performance? So now we're not so worried about whether a given model can or can't replace a person. Would it? Is it going to improve business performance? Will it reduce risk? Really important questions. Let's see what we can answer. So, oh dear, what's the thing? 2 books I encourage you to either read or actually what I did for certainly prediction machines was go on YouTube and find a Jay Agrawal, actually any one of the authors. They did an incredible book tour where they give a lot of the ideas. And if you want to dive deeper, get the books. These are unusually good because they're pretty kind of calm, economics-based view of what AI could do. And there's some ideas in here that come from that. So let's first look at a microeconomic view. For the economists out there, I'm using these words a little loosely. But what does AI even do? So we talked about prediction is taking information you have and filling in information you don't. It's decimated. Machine learning has decimated the cost of this, leading to an ongoing explosion of applications, right? So what does that mean? Well, that means that things that use predictions as an input are going to have an impact. And what's cool about this is the economics of inputs is not new. So it's making things that are made up of predictions essentially free, close enough anyway. Clerical work, some of junior level management, classifying, generating first drafts, and so on. The thing to keep in mind about this before we get, caught up in oh my gosh, it's going to be a jobs apocalypse. I mean, it's a cute headline, but the reality of what actually happens is when an input cost is reduced, other entities that do similar things will lose value. So if you are competing directly with an AI, you're going to have a problem. But if what you're doing uses what an AI does, actually your your value goes up. So complements gain value. Um, Competitors and substitutes, excuse me, lose value. An example of how that played out in the real world within some of our memory is when ATMs first came out. Everyone freaked out and thought it was going to be the death of the bank teller. Turns out that the things that you could have an ATM do were some of the lowest value things a bank teller did anyway. So it wound up making people go to the bank more because it was faster and cheaper and easier to just go to the ATM. And there ultimately were more jobs for bank tellers because there were more branches. So that's not always going to be the case, but it is an example of how not every time you automate a thing, there's a net loss of employment. Sometimes there's either a shift, and often that shift is up the value chain where people are enjoying their jobs a little more than just handing out cash. As much fun as that can be. So related to that is you would ask yourself, well, what is a job? So, think of it as a collection of functions and capabilities. Any job, any given job is going to have functions that AI can do better. They may be not very important to that job. Sometimes they'll be more important to that job. So most jobs have functions that also use AI that the AI itself can't do. So I think our role as people who are in this industry and interested in its health and success is to say, how do we break down what our roles encompass, then map what's AI replaceable and map what's human essential. Typically, AI replaceable, even in the world of large language models, is things that are routine, things that are constrained, things that are repeated. Human essential are things that require world knowledge, that require judgment, that require sophisticated judgment and kind of intuition. Ultimately, the things that a lot of people enjoy doing more anyway. This is a rough way of looking at it, but hopefully it's helpful as you think about your own job, but also the company where you work and how that may or may not change over time. So the last part here, and I am ending a little earlier than I thought I might, is actually I've got two more things, but the separation of human prediction and human judgment. Really interesting that AI is now doing some of the prediction, and that filling in gaps, classifying things, doing some of the early steps of making a decision or executing something. AI will help with this, but ultimately it's the human judgment that is still there's no replacement for it. There's nothing, we don't know how to do that yet, and I'm not sure we're close. But certainly within a time frame we care about, this is what you're going to start to see is the tools we make become more powerful. They free us to be able to spend more time thinking, spend more time understanding a problem, and less time shuffling paper around. Just not shuffling paper around is the kind of thing that would enormously, I think, help both mental health and productivity. One of the things that's important to think here also is if you're familiar with the concept of deep work, one of the best ways to destroy someone's ability to do deep work is to have them spend a lot of time shuffling paper and process and reacting to things. So being able to automate at least some of that, I think gives people more ability to spend time on the deeper issues and thinking about what they're doing, not just executing all the time. So on the macroeconomic side, this is a really interesting one, and there's a lot in here that I encourage you to read the second book, their Power and Prediction. But Sundar Pichai, the CEO of Google, is one of the people who said something kind of big and statementy like this: AI is more important, a more important development than electricity. I'm kind of paraphrasing. It's a little bit like when they said data is the new oil. It's like, okay, I hear you. The point is, it's really important, and it has the potential to really transform what we're doing. Because of that, I like the idea of taking what electricity itself looked like. When we take it for granted, it's everywhere. But it turns out in the first wave of electrification, it didn't grow that fast. It was surprising to us looking back where it seems obvious. But what happened was, especially on the business side, they wound up they tried anyway to use electric engines to replace steam engines. And what wound up happening is it didn't change the way steam engines were the way that the factory was being used very much. When things really changed was sort of the second wave, where they created what they called applications, where they started changing the way the factory worked. So not only did they put machines, electric engines at every little area or every little station in the factory, but they also started to change the way the factory was laid out. And that's the exciting thing that happened next, is ultimately the assembly line really changed how manufacturing works. And that didn't happen right away. It took a little while before a key constraint was understood properly and was relaxed. And the constraint at first was that everything needed to be near the steam engine, which meant everything was collected around, everything that needed power was around one engine. Once you were able to disaggregate the engines and the power, suddenly you could make the work itself the organizing principle, not power. And that takes a minute to think about and sort of abstract and say, all right, well, what are we doing? How are we thinking of our constraints in those ways? Many technologies start off being used in the same position of the ecosystem as what they replaced. And again, electric engines and electric engines and steam engines are an example of that. Radio was used like theater, TV was used like radio, and then later web was used like print. It takes a while for us to really understand the new medium, the new technology, and use it in a way that is native. We use it in a way that we're really understanding the change it can create. And that's our job. And when I say that, I mean everyone on this call in our industry is understanding what's the constraint in our process that's kind of like the steam engine. What did we organize around that's no longer true? What is AI, especially generative AI, change about the constraints in our business that isn't true anymore? Like whether it's writing or whether it's classifying things or whether it's reading things and summarizing them. Some of us have just enormous numbers of the same kind of document. I think I saw Dan Broderick on the call, and one of the things he points out is smaller contractors often have like dozens and more of the same contract that they can't read. Just being able to process those properly changes a constraint that particular business had. And once you've changed that, once you understand what that constraint is, like the first question probably is, how do we reorganize construction without that constraint? I'm focusing on construction, but really it's an overall AEC question. Is now that we're not bound to paper that has to be passed around, and we're not bound to a human needing to read every line every time. What constraint has changed, and what do we think we can do to reorganize construction? This isn't an answer that we have today. This is an answer that I think we're going to have to iterate our way to. It wasn't obvious that when you put electric engines near every part of a factory, that the right thing to do was to turn it into an assembly line. That took some time and some creativity. And I think that's where we all are right now, is we've got some constraints that have changed, but what do those constraints even mean? And how do we reorganize things in a useful and interesting way? To do that, I'm just kind of putting a plug in. Next month, we'll have a similar, but I'll have two guys from the field that have had field experience talking about how AI in construction workflows works to start to explore that problem. And we are now coming sort of towards the end. I want to end with what you can do if these are interesting and you want to dive in deeper. The first thing is to read those two books that I just mentioned. The next is go to deeplearning.ai. They've got these short courses that are only an hour. You can absolutely ignore the code part of them and just listen to them talk. And there's great stuff in there. Really, really cool. Lightweight. It's only an hour, like I said, and of course it's broken up into 5-minute sections. I really like this. I think it's very valuable. Spec GPT, a demo that we've created. We've got a beta that you can sample and try. I'm happy to follow up. I don't want to linger on this too long. But it's basically we allow you to upload your own specs and just play around with questions and ask, and it basically interrogate the questions, interrogate your specs. And then at the end of it, you can delete all your data. We're not trying to gather data. We're out there hoping people will learn and have fun with it. And I think the final point I'll leave you with is don't get distracted by talk of killer robots. There's a lot of that going on, and it's salacious and it's fun to hear. But the truth is, what we've got now is a set of products that are acting like every other technology, for 100 years. That there's some promising things being done with it. A lot of it's up to the entrepreneurs and their partners to create and iterate so that real value is being created. The other thing, though, that I think is more true than has been true for some other technologies, this is the moment when the AEC industry needs to be looking at process and really rethinking how we do what we do, because I think that's when the real benefits, I mean, I'm not alone in thinking this, that's when the real benefits come. Thank you all. Here's my email. You obviously all have connected with me on LinkedIn one way or the other. Now I'd like to jump into Q&A. I'm going to start actually. Well, let's open it up, and I'll answer some of the questions that were in the in the chat. Anybody have any questions or thoughts?
Hey, Hugh. So here a couple of days ago, ChatGPT announced GPT Enterprise. I guess my question to you is, what excites you about that, and what do you feel like the challenges people need to be aware of when they're trying to leverage those LLMs against their own data sets?
That's an excellent question. So I think ChatGPT. So there's let me broaden my answer one little bit. We are used to, in the software world, infrastructure providers like Microsoft with Azure and obviously AWS being the big example. ChatGPT has made clear they're not going to behave like that. So they're going to make end user products as well as sort of infrastructure. So that's one interesting point for people that are on the kind of contractor or firm side as you're thinking about what to do. The fact that they've now really put up walls to say, which is I think part of what your point was, put up walls to say your data is not going to leave, I think is great. I think Azure did a thing like that too. So I'm not 100% sure how best to answer your question, except to say that what it said to me was that watch this space. It's still going to move super fast. I mean, I would argue at least as interesting as that is Llama 2 being made free. And it's a really powerful model. So the space is moving super, super fast. But Rob, do you want to ask that question a little again? Like when you asked the question about what to do with your data, what specifically were you thinking about?
Well, I think from my perspective, I think it's exciting that that they're opening up their tech to be able to apply against using their LLMs and everything else to apply against our data sets. And I guess from my side, if the rest of my C-suite and leadership went out and read something about this and they're like, hey, great, now we're going to go do this, I would still caution them, kind of like we were talking about last week. We've got to make sure that the underlying data sets are right, because we don't want it learning from bad data, right? We want it to learn from good data sets, so that good improvements across all these things that you talked about today, and the automations and the augmentations and things like that, can be achieved. I think that's the caution that I would have. So I'm excited by it, but at the same time, I want to make sure that we're taking the right approach and not just leaping into the deep end of the pool.
I agree. I think what LLMs are a little different in that how they do or don't learn is a little less a concern. It's not a concern, but you're often taking a model that's been trained already and maybe fine tuning it. The thing is, there's really three parts, and I probably should have included this, but we will in a later one. With an LLM, there's the embedding process. So what are the documents I'm looking at? And that on its own is its own model. There's an AI that does that. And then there's the AI, the large language model that gives you your answers. So it consumes from that embedding. So that it's a little, the tools that get you there are more important than they were with deep learning, where most people didn't really know what embedding was, even though it's happening then. Does that make sense? So I think what's critical for anyone at enterprise level is to really dig into what the parts of the tool chain are, and what are the sensitivities. I mean, to your point about documents, now I would be less concerned about bad data training it than you pointing it at the wrong data and it answers a question doing its best, but you've had it you know what I'm saying? Like you've had it include the wrong data. So making sure that you've got real good data lineage about what's going where and how it's being directed in the right place, if that makes sense, is important, because it's really powerful, and it's going to include what you give it. And if you gave it, if you're asking a project question and there's a document from the wrong project in there, which of course never happens, it's going to give you an answer. So I think understanding the LLM tool chain and that's one of the reasons I like the deep learning, is that like in an hour, you can just really understand embeddings a little better. You can understand fine tune. They've got a whole course on fine tuning, which I think is really nice. It's not crazy, Rob, that a company at your size and above is going to have multiple models that you've tuned to do different things, to be really good at answering questions about concrete or about project risk or just indemnification. Just that, you may wind up with a model that's good at that, and then some system that allows you to swap in the right model for the right problem. Does that make sense?
Yeah, and what excites me by this is 3-4 years ago, starting to build out the foundations of data modeling in a way that we could start to get from the lagging to the leading to the predictive to the prescriptive side of things with our own data sets was more of a massive undertaking. You had to have true data scientists on your team. There's a lot more to it. So what excites me is that we don't have to have as many of the people to help get through this, that this could potentially leverage. We were trying to answer the question 4 years ago in a more succinct way with, like I said, all the data science behind it of, tell me of my top 20 jobs, which ones are the most likely to have a 1% profit fade over the next 6 months? Something like that.
Yeah.
And so that's where this kind of excites me, is we can get to those answers quicker with a good foundation of data to build off of without having to go get $1 million of payroll to make it happen.
It's funny. I think you're right. And the other side of it is the gold rush of trying to lock everybody in meant that you were very well paid as a data scientist, and suddenly Silicon Valley was like, oh, I don't know that I need to have spare capacity of quite this many. Yeah. So it's like you build a bunch of chip fabs and suddenly there's a glut of chips. I think they're still well paid, but it's not as brutal as it was. But you're right. I don't think you need the same level. You can get good things done without the same level of data science. Actually, so Mark Goldman asked a question about AI and knowledge graphs. There's totally an intersection between the two. Actually, Paul, do you want to hop in? You gave a great answer. I got to be honest with you. I've looked into it, how knowledge graphs overlap. There's a lot of application there, but it isn't something I'm as deep on as you seem to be, Paul. Would you be comfortable hopping in if you're still here?
Yeah, sure. Can you hear me?
Yep.
Great. Yeah, absolutely. So I've worked for a number of years with the technologies. Knowledge graphs, I found a lot of value in identifying content that was really important to whatever the business scenario or business problem was. Identifying that high value content to do the training of a machine learning model, which is different than an LLM. And I see, Marcus Turner, you posted a link to a YouTube video. I'm really interested to see that. I will watch it later tonight, probably. But I have not quite found the same way to leverage knowledge graph technology to make an LLM better. And the reason for that is really around, what an LLM is. It's a deep learning model, and it needs just more data, more. And it's less about sort of the biases and the weights of things that go into creating a machine learning model, where a knowledge graph to identify the really high value content comes into play. Does that help?
Yeah, well, I'll bet you what you're going to find is that people are using LLMs to help create knowledge graphs. That's the sort of thing I think they'd be good at. For those of you who haven't spent any time with knowledge graphs, they're a way of organizing data that is more about the relationship and less about strict categories. And it's really cool, really valuable in a industry like construction, where you've got so many different verticals that are, or silos, for lack of a better word, that relate to each other. Really interesting. So I'm looking, I think there's a lot of back and forth. Does anyone else have any thoughts or questions you'd like to ask about or share with the group? I'll give it a minute and then. Awesome. Well, listen, thank you all for joining. I love this topic, clearly, and we'll do it again. Next month on the 21st, we'll have a little bit more of a focused conversation around workflows. I'd love any questions or thoughts anyone has prior to that. And we'll look forward to doing this pretty regularly. The next one of these, where it's a kind of high level AI briefing, will be at the end of in November, at the kind of part of Q4. I'll aim to do one of these once a quarter. Lots still left to cover, lots still left to discuss. So as I say, thank you everybody, and reach out if you'd like to.
Great job, Hugh. Appreciate you putting this on.
Thank you.
Thank you.
Thank you.
Thank you. See you.